Let's talk more about the processes that occur in the electrolyser. Let's take a closer look and delve into our topic. So as you see in this picture, we have a vessel with a certain volume, and this vessel is divided into three parts. Middle part, the volume of water that is near the anode and the volume of water that is near the cathode. We assume that these three parts of the volume are equal to each other. Here is volume UA, here is volume S, here is volume OK. That is, OK is a volume near the cathode. Where is the volume near the anode? They are in the middle, as I say, they are equal. So we re-looking at stage E. Stage E is when we have a tense break. We see in the picture that a water molecule in the middle zone has exploded. Accordingly, the minus oxygen goes towards the anode and sticks to the anode. Minus hydrogens, they go towards the cathode and stick to the cathode. Thus, we can assume that the volume of us, it does not participate in electrolysis, it does not give brown gas, but the volume that is located near the anode. We see the molecule ruptured, and the oxygen suboxygen jumps to the plus anode. And plus hydrogens, they float, they cannot break through the middle zone. That's why they pop up. In turn, in the volume GOK, that is the volume of water near the cathode, we see a similar process, only on the contrary, the molecule we have ruptured and plus hydrogens. They restuck to the cathode and suboxygen. It comes out as brown gas, and we get this. Brown gas gives two zones, a zone near the anode, a zone near the cathode, and if we add up the released brown gas, we will get this volume gas, relatively speaking, to understand the logic. The volume of gas emitted will be equal to the volume of one of these zones. We assume that these zones are equal in volume. This is where we had stage where we have direct current with a certain amount of tension. We have standard electrolysis. Let's move on to the next slide, and this is mere electrolysis. When we have stage after stage, that is, the voltage is turned off. In step, the molecule burst. And then in step if turned off the voltage, respectively, broken oxygen and hydrogens, they float to the surface. So it turns out the volume of faucet completely gives brown gas. That is why the volume of you gives. It's half of its volume in hydrogen, and it sticks to oxygen. Why? Well, because the residual potential of the electrode functions, it still remains. I just showed you how the residual potential is close to 0.5 volts. Respectively, at the cathode residual potential minus 5 volts. 5 volts causes positively charged hydrogen to stick to the cathode and charged oxygen floats. That is, we get half the volume of hook involved in education. We get half the volume of involved in a brown gas, and half of your volume contribute to brown gas formation, and the entire volume is involved in the formation of brown gases. So basically, we have mere electrolysis. It gives brown gas twice as much as standard electrolysis. But Meyer decided to add more. Property as acoustic resonance. We see that these sticky atoms, oxygen and hydrogen atoms, can be dropped from the cathode and the anode. How does he do that? Look, it adds vibration to the tubes. The tubes, they vibrate. They vibrate. They throw themselves off, so the anode drops an oxygen atom vibrating. A cathode throws off hydrogen atoms vibrating, so that we have the entire volume of UA involved in the formation of brown gas, the entire volume of UC involved in education. Brown gas. And the entire volume of us is involved in the formation of brown gas, that is compared to standardized Meyer electrolysis plus acoustic resonance gives brown gas 3 times more than standard direct current electrolysis. Let's make it clear. I'll run a dynamic picture. Well, that makes sense. What's the difference? Here's the stage if going on, no vibration. Stage if with tube vibration as they drop off. Here's the stage where we only have the rupture voltage, again stage if. As you can see, what we do is we don't have a constant voltage. We have a pulse current that gives us, compared to a constant voltage, twice the amount of brown gas. And we have tube vibrations. Acoustic vibration of the tubes, which gives 3 times more than standard electrolysis. These are the models used by Stanley Meyer. If we look at all his patents show formulas from classical physics. It says something. It suggests that his models have no such thing as resonance of water molecules, resonance of oxygen and hydrogen atoms, because in this case, if this resonance is present, then Meyer's patents should. There are formulas from quantum physics, from quantum electrodynamics, but he has no such formulas in his patents. Accordingly, there can be no talk about the resonance of water molecules and the resonance of water atoms. That's my conclusion. If anyone disagrees, you can leave your comments. As long as I'm on it. Music.